Difference between probability distribution and binomial probability distribution. Number 1, requirements for probability distribution. There is a numerical random variable x and its number values are associated with corresponding probabilities. So for instance, if I draw this example and I ask you whether this example satisfies probability distribution requirements or not. So I'm going to say my random variables are 0, 1, 2. The associated probabilities are 0.25, 0.50, and 0.25. So number 1 says each random variable has to have an associated probability. In our case, yes. So the first condition satisfied. Second one, when you add up those probabilities for each random variable, has to be equal to 0.11. In our case, yes. Third one, each probability for each random variable has to be between 0 and 1. 0.25, yes. 0.50, yes. 0.25, yes. So the third condition satisfies as well. If one of the condition fails, then the entire probability distribution fails. That means it's not a probability distribution. For instance, let's say if this value was not 0.25 but 1.25, then as you notice it, when you add these two up, that's no longer, the sum is no longer 1, it becomes 2. So if it became 2, then the second condition failed and the third one failed also. But if one of the condition fails, then the entire distribution fails. So you don't even have to worry about checking the next ones. But it's good to check it to see if you have made any mistakes or verify double time. Now, very important note. With a probability distribution, we have a description of population instead of a sample. So the values of the mean, standard deviation, and variance are parameters and not statistics. So what that, in short, it means that when you write the symbols for mean, standard deviation, and variance, it has to come from population symbol. So mean has to be mu, standard deviation has to be sigma, and variance has to be sigma square. Now let's remember what parameter and statistic was. Parameter is a numerical measurement describing some characteristics of a population, and statistic is a numerical measurement describing some characteristics of a sample from our chapter 1. So the formula for mean for probability distribution is you multiply your random variable x with probability p of x and you add them up at the end of the day for each random variable. Sigma is you do x squared times p of x, then you sum them up, then you subtract your mean from it, you square the mean and you subtract, and then take the radical. And the sigma square, you square on both sides, so you get sigma x squared times px minus mu squared. So these are the three formulas for mean, standard deviation, and variance. Let's go next here on this side. Binomial probability distribution. 4 important requirements: fixed number of trials, trials must be independent, each trial has outcome classified into 2 categories, success and failures, and probability of a success remains the same in all the trials. A binomial probability distribution is a particular type of discrete probability distribution. So if you remember, x are the discrete numbers, so, or discrete values you can say. So we could use these formulas here to find mean, standard deviation, and variance. But if we know the value of n, which is fixed number of trials, and then p is a probability of success in one of the n trials, and q is the probability of failure in one of the n trials, if we know that, then it's easier to use this formula. So mu is nothing but n times p, sigma is square root of n times p times q, and variance is you square on both sides for your standard deviation, which is n times p times q. Hope this will help you to see the difference and to approach to your problems with an easier way than doing the long way or hard way.